Hi everyone, this is Miss Crook and this is an intro for today's lesson, which is on slope fields. I'm going to do this first because I need my computer, and so I am trying to do a picture-in-picture shared screen, and we'll see how it goes. Quick review of things we already know because it makes us all feel good. If we have that the dy dx, or the derivative, is secant x tan x, we learned over the semester that the solution, or the antiderivative, would be secant x plus c. Good job. I heard you guys all yell plus c. That was awesome. If we have that the dy dx is x squared plus 5, then we learned throughout our time together that the solution, or the antiderivative, would be 1/3 x cubed plus 5x. What's that? Plus c. There you go. And then later in the semester, we did harder problems where we would have dy dx equals perhaps negative x over y, and we didn't know the antiderivative, so we had to use a trick. And tricks that we learned included u substitution and separation of variables. Okay, so here's what we're going to learn how to do today. We are going to learn how to draw something called a slope field, and I'm going to do that in a separate video with your note-taking guide. But the way a slope field works, and I'm going to teach you how to draw this, is we are going to sketch something similar in our note-taking guide. And if you see over on my computer, I said dy dx equals negative x over y. And then you look at your picture, you look at your field. If you have taken physics, Mr. Balmy refers to this as a vector field to try to determine what a solution, what a position curve is when given velocities. If that made no sense to you, doesn't matter at all. You'll all be able to do this. So this is a slope field, and you would look at this field and what does this look like? What shape is jumping out at you? For me, it would be a circle. If I put my cursor in any spot and then I just kind of traced or followed my nose, it looks like a circle. And so what a slope field can do is it can give you a really good indication of what the antiderivative is, what the particular solution is when you have a dy dx. That is particularly helpful when you do not know how to integrate something. Before we get there, let's go back to the negative x over y, and let's just for fun remind ourselves, because we will need it for this unit, how to come up with the antiderivative, because this is actually one that we do know. So if I have dy dx equals negative x over y, and I want to come up with the antiderivative, we learned separation of variables. And that's where you get your y's with your y's, and you get your x's with your x's, and then you integrate both sides. So we went ahead and we had a c on both sides. We learned that then you want to solve for y, and a c make a c. We learned that we would isolate y by multiplying everything by 2, and 2 times c is c. Hopefully this sounds familiar. I know you haven't heard my voice in a while. And then usually we would do root it plus or minus to get the y by itself. But I want to stop right here so that you can see the connection between this and what's on my computer screen with the circle. I'm going to switch the order of these so that maybe if you didn't notice that it's a circle right here, you see that it's a full circle right here. So this is a problem that we do know how to integrate. And when we integrate it, we get that the antiderivative, the solution, is a circle. But our slope field could have told us that story too. So what I'm going to teach you how to do today is draw a slope field, because you will encounter problems, now that we're at the very end of the course, that look like this. I don't have the antiderivative memorized. I can't use u sub. And I can't use separation of variables. If I move the dx up, I can't exactly move the y down. So what you would do if you move on in the course, if you take further calculus classes in college, is you would draw a slope field or plug in your derivative into a slope field generator, and you would get this sketch. And then this is going to be easier for me to teach you with pencil and our notes, but basically this sketch of the slope field tells us our story. It tells us that the antiderivative would look a certain way, even though we can't come up with the antiderivative ourselves. So this is what we are going to learn about today. I'm going to go now to part 2, and I'm going to use a note-taking guide that I actually was able to distribute to you before we had to separate, so you should have it in your possession. If you don't, you can also find it in modules and reprint. Okay, let me try to figure out how to stop this. 1 second.